With the GoE controller, you can manage the energy flows within your building. Depending on the position of the sun and your current power demands, you can control your electric car's charging process even smarter when combined with the GoE charger, and gain an overview of your home's main electrical loads. But when you install the GoE controller, what should you look out for? And how do you set it up? That's exactly what I'll explain in this video. But before we get started, don't forget to hit subscribe to our channel and tap the notification bell so that you will always stay up to date with the latest information. Hi, welcome to the GoE YouTube channel. My name is Amy, and first of all, it's important to mention that the GoE controller must be installed by a qualified electrician, since the installation must be carried out in accordance with the applicable local, regional, and national regulations. Before installing the GoE controller, make sure to read our quick start guide that comes with the device, the installation and operating manual, as well as the controller's data sheet, and you'll find all of these documents on our website. But whether you're a qualified electrician or not, stay tuned, because I'll not only explain the installation steps, but also show you how to set up and operate the GoE controller via the display. All right then, let's start with the basic installation. For the installation location, we recommend an electrical distribution board that offers space for at least 4 modular units for the GoE controller and possibly a little extra room for a new circuit breaker. Alternatively, it is also possible to install the GoE controller in a new surface-mounted or flush-mounted distribution box next to it, and then route the connection cables for voltage measurement and the current transformers to that box. So, step 1, make sure that the system is completely voltage-free according to the 5 electrical safety rules. Step 2, mount the GoE controller on the DIN rail. It can be installed either in the standard position or rotated 180 degrees depending on your preference. Rotating the device isn't a problem, since the display orientation can be changed later via the menu under Settings, Device, and Flip Display. Step 3. Now connect the GoE controller with either a single-phase or 3-phase connection. The controller itself consumes hardly any power, so it can also share a circuit breaker with other devices, for example, a kettle or an electric cooker. If that's not possible, you'll need to install a new circuit breaker. Always make sure to follow local installation standards. Insert the conductors into the connection terminal of the GoE controller and secure them with a screwdriver. Also, connect the neutral conductor and the protective earth conductor. Step 4. For a 3-phase connection, plug the jack plugs from the 3 current transformers into the corresponding inputs for current measurement. For example, into sensors 1 to 3. For a single-phase connection, you'll only need 1 current transformer. Step 5. Next, attach the current transformers. For PV surplus optimization, we need enough sensors to measure the power going to and from the grid. The easiest way to do this is by measuring directly at the grid connection. However, it's also possible to measure the load branch and the PV inverter separately. The GoE controller can then add or subtract these values. In most cases, it's easiest to measure directly at the grid connection. Here we use 3 current transformers. Phase 1 connects to sensor 1, phase 2 to sensor 2, and phase 3 to sensor 3. The 2 arrows on each current transformer must point in the direction of current flow. When connecting to the grid, which we refer to as the mains, the arrows should point from the grid towards the house. For a solar inverter or AC battery, the arrow should point from the inverter or battery towards the distribution board. When measuring other loads, such as a boiler, the arrow should point towards the load. By the way, if due to space constraints, it's not possible to install the sensors in the indicated direction, you can invert the sensors via the GoE controller's menu or the GoE app. I'll show you how to do that later. This reverses the measured current flow so that the correct values are displayed. Step 6. Now let's see how you can connect your PV system, battery storage, or other electrical loads to the GoE controller. After performing direct measurement at the grid connection, we can use the remaining 3 to 5 current transformers to measure the power flows of different devices or consumer groups in your home. If you want to measure and visualize your PV production, you must measure the current on one phase of your AC PV inverter using a sensor. Just a quick reminder, PV optimization is also possible without directly measuring the inverter's production. However, with an AC inverter, using a sensor allows you to additionally see how much power the system is generating in total. If you have a battery storage system that should be included in your energy optimization, then use one current transformer to measure one phase of the battery system. Please note that this is only possible with AC coupled batteries. You can also use the current transformers to measure the consumption of individual circuits, such as lighting, a boiler, air conditioning, a sauna, or a heat pump. Now, plug the jack plug of a current transformer into one of the remaining current measurement inputs labeled sensor. You can assign them freely. For example, let's use sensor connection number 4. Clip the current transformer around one phase of the device or circuit, the current of which you want to measure. For 3-phase devices that draw the same power across all phases, such as an AC inverter, measuring just one phase is usually sufficient. Again, make sure that the 2 arrows on the current transformer point in the correct direction of current flow. It's not possible to clip a single current transformer around several phases at once, even though that might seem convenient for something like an electric cooker. And once again, a quick reminder, if there's not enough space to install the current transformer in the right orientation, you can simply invert the sensor. We'll show you how to do that later. Step 7, depending on which connection options you have available to you, connect the Wi-Fi antenna, LAN, or Ethernet cable to the GoE controller. For the best reception, route the flat Wi-Fi antenna cable outside the distribution board and attach the antenna head there. Once you've installed all the current transformers you need, you can restore the power supply. The GoE controller will now power up, and once the system has booted, it's ready for operation. At this stage, you'll probably see incorrect measurement values on the display. That's because we still need to assign the correct phase and category to each sensor. All right, let's move on to the initial configuration of the GoE controller. For the initial setup, you can choose between 2 methods, either directly via the controller's display or remotely via the GoE app. In this video, I'll show you how to set up and operate the GoE controller using the display. If you prefer to set it up using the GoE app, we've prepared a separate video for that as well. If you already have one or more GoE chargers installed, they'll automatically be detected by the controller once its configuration is complete. It's important that the GoE controller is on the same network as your GoE chargers. When using Wi-Fi repeaters, make sure that they extend your existing home network rather than creating a new network with a different IP address. The best compatibility is usually achieved when the repeater and your router or access point are from the same brand. By the way, there's no limit to the number of GoE chargers you can connect to your GoE controller. All right, now let's take a look at how to set up and operate the GoE controller using its display. As you can see, the GoE controller has 4 buttons next to the display. You'll use them to navigate through the display menu. Once the GoE controller is ready for operation, you'll already see the first measurement values on the home screen. These values are likely still incorrect for now, but don't worry, we'll get to the sensor configuration shortly. You can access the main menu by pressing this button here, without selecting any category. Use the up and down buttons to move between the different menu items. If you want to select a menu item, press the right arrow button. To go back, press the left arrow button. Let's first take a look at how you can adjust the language or display of your GoE controller. In the main menu, go to Settings, then select Device. Here you can, for example, rotate the display if you've installed the controller upside down, change the language, or adjust the brightness of the display. Once you've decided these basic settings, press the back button to return to the main menu. In the Sensors menu, you can now start the configuration. In this menu, you can already see voltages, currents, and power values in real time. L1 to L3 show the voltage of the phases connected to the terminal block, and N indicates the connected neutral conductor. I1 to I6 display the values of the connected sensors or current transformers. I here stands for internal, which corresponds to the connected sensor. If you select L1, L2, L3, or N, you'll access the voltage settings for that phase. In this overview, you can see all measured values from the sensors assigned to that phase. Just check whether the voltage appears roughly correct. If the current or total power doesn't yet match, that's fine for now because we'll get to that part later. Press the left arrow button to go back to the sensor overview. If you select one of the 6 current sensors from the overview, for example I1, you'll access the corresponding load settings. If it turns out that you've installed a current transformer in the wrong direction, you can invert the load using the slider option, which reverses its polarity. For accurate power calculation, the phase reference must be set correctly. Imagine the sensor measures 2 amps on your mains connection. Without a voltage reference, the controller can't know whether you're feeding power into the grid or drawing from it. In general, power should show as positive when you're importing energy from the grid. For a solar inverter or an AC battery, the power should be positive when exporting to the grid. However, when the battery is charging or the inverter consumes more in standby than it generates, the power can be negative. When no current is flowing, the power value should be close to 0. It's very important that the correct phase is set as the voltage reference. You can find out which phase your sensor is connected to by tracing the cables in the distribution board. Alternatively, you can use a multimeter to check whether the voltage at the GoE controller matches the circuit breaker of the respective load. The power factor can range from -1 to +1. -1 represents maximum export or battery charging without reactive power, while +1 represents maximum import energy production. If the power is very low, the power factor isn't particularly important. For purely resistive loads, the power factor should be close to 1. To test the phase assignment, simply switch on a large resistive load in your home, such as a fan heater, hairdryer, or electric cooker. If your cooker is connected via 3 phases, that's especially convenient since all 3 phases will show a power factor of almost 1 simultaneously. If the power factors on 1, 2, or all 3 phases appear incorrect, for instance, only showing plus or minus 1/3 or plus or minus 2/3, you'll need to adjust the phase assignment. Until the assignments are correct, the controller won't be able to distinguish between grid import and export, and PV surplus charging will not function properly. All right, now let's take a look at the categories. The GoE controller doesn't automatically know which sensor you've installed where, so we'll define that using the categories. There are several categories available, and the most important one is the category grid. This category is crucial because the GoE charger and the GoE controller work together to keep the grid import as close to 0 as possible during PV surplus charging. Let's look at 3 examples to understand this better. If you've installed a sensor directly on a phase of your grid connection, you should set the category grid to 1. If you don't measure your household consumption separately, you should also set the category home to 1. This means that all power measured on that line is automatically assigned to grid import and household consumption. If you've installed a sensor on the line of your PV inverter, you can assign its power directly to the solar category. The power should show as positive whenever the inverter is producing solar energy. If you measure all phases of a single-phase or 3-phase inverter, select factor 1. However, if you have a 3-phase inverter but only measure 1 phase, you can select factor 3. This tells the controller to multiply the measured value by 3, as we're only measuring 1/3 of the total power. Now, we also need to assign the solar power to the home category. Let's take a quick look at a calculation example. You're importing 1 kilowatt from the grid. You're generating 500 watts of solar energy. We've already assigned the 1 kilowatt grid import to home. Since you're producing an additional 500 watts yourself, your total household consumption is 1.5 kilowatts. Therefore, assign the PV inverter to the home category as well, with factor 1 or 3, depending on how many inverter phases you're measuring. Let's assume you're measuring both the load branch and the inverter on all phases. In this case, your categories will look slightly different. You'll need to subtract the solar production from the grid measurement, so you'll set the factor to -1 for the solar measurement. If you're measuring just a specific device, for example, a boiler, you can assign it to a custom category, such as Custom 1. You can rename this category later if you like. There's no need to assign this to grid or home since you're already directly measuring these currents. If your solar inverter is installed too far away from the distribution board with the GoE controller so you can't measure it directly, that's not a problem. For PV surplus charging, direct measurement of solar production isn't required, as mentioned earlier. However, if you'd still like to monitor your solar production, you can buy a second GoE controller and connect it to the first one via your home network. After identifying the correct categories, you can set them in the menu. In the submenu, define which sensor value should be assigned to which category and with what factor. For a 3-phase grid connection, assign the same input values to internal 2 and internal 3 as you did to internal 1. The next steps I'll show you are optional. They're only needed if the voltages at the controller's connection terminal are not wired in the same order as the phases in your distribution board. If your sensors are already set up correctly, you don't need to change anything here. If you select Sensors in the main menu and scroll all the way down, you'll find the voltage phase assignments. Navigate through the lines and select the phase you'd like to adjust using the right arrow button to correct any incorrectly connected phases. Next, let's take a look at the network settings so you can connect your GoE controller to your network and to your GoE chargers via the Wi-Fi or LAN. In the menu, go to Settings and choose Network. Here you can enter your Wi-Fi credentials or configure your Ethernet or LAN connection to ensure that the controller connects to your network and can communicate with your GoE chargers. Please note that a network connection is essential for PV surplus charging and dynamic load management. It also allows you to connect the controller locally via the GoE app without using the cloud. Here's a quick tip. You might even find it easier to configure the Wi-Fi and Ethernet settings directly in the GoE app. I'll show you how to do exactly that in one of our other videos. All right, now it's time to connect your GoE controller with one or more GoE chargers. You can actually connect as many GoE chargers as you like. In the main menu, select Chargers. For the chargers to appear on that list, the GoE controller must be on the same network as the chargers. As mentioned, you should configure the network settings under Settings and Network. Once connected, you'll see a list of all available chargers. If a charger shows paired, it's already communicating with the controller. If it shows found, the charger is not yet ready to communicate. This can happen if, in the GoE app, the automatic search for a controller hasn't been activated for that charger, or if the charger is already linked to another controller. That's because each charger can only be connected to one controller at a time. If you've already connected a GoE charger, as in our case, it will be displayed as paired. If you select a connected charger, you'll see more information about its current charging status, such as current, voltage, and so on. Please note that you can't configure charging or dynamic load management settings here. Those need to be done directly in the GoE app. Now, let's go back to the main menu. If you'd like to view the current power of the individual categories, select Power. If you select Energy, you'll see the current energy consumption in watt-hours for each category. Under Settings, you can adjust various parameters such as time settings, cloud settings, network settings, and other device-specific options. If you want a summary of the power and energy data for all categories, you can find it in the Categories menu. For certain functions, and depending on your GoE charger model, you may need an active cloud connection. To configure this, go to Settings and then choose Cloud, where you can enable or disable the connection. If you're an integrator or an expert and you want to explore more advanced options, such as activating the local HTTP API, setting up MQTT or MEC meter connections, or enabling Modbus, you can also do all of that directly via the GoE controller display. I hope this video was helpful. If you've got any questions, just drop them in the comments below or visit our website. You'll find all the links in the description. I'll see you next time, guys. I'm Amy from GoE.